So let us, I'm going to move that down here. Let us build a simple mock-up propeller. So I'm going to create a cylinder again. I'm going to rotate it to its side. I'm also going to create a cube, just something like a direction indicator. So basically one single prop blade. I'm going to move that up. I'm going to extrude that out, move it a little bit up, and extrude that again. Come on, Maya. So face, extrude that. So and I'm going to scale them here. So that's our little mock-up prop. I'm going to combine these two to a single shape, delete the history, so we can rotate that. And in fact, we're going to do that. So let me just put another keyframe on frame 20. And it's rotate Z, so let's put that to 360 degree and go back to the graph editor. Oh, it's always going to open on a second monitor, apparently. Why ever? Rotate Z, and is it actually rotate Z? No, I didn't set a keyframe, so yeah. So that's that. So linear. I'm just gonna set post and pre-infinity. So it's just your that's just your standard rotation animation that will just keep constant over time. And let me just quickly add a Arnold Skydome light here, and I'm gonna hide it in the viewport. Where's the viewport? There's the viewport tab, so make it small so we don't see it, and I'm also gonna hide it in the rendering, so we want to render in front of black because we're just gonna see things a little bit better. I'm just gonna save that here because I will be using a lot of time steps while rendering, so that's rotor example rotor example e01.mb, and it shouldn't, but things might crash when running the IPR with that many motion steps. Sometimes it does. So just to make sure that we don't lose much, I'm just going to save that. So this is rotating now, and this is actually rotating pretty fast right now. So it moves, how much does it move actually? So it moves a full 90 degrees per frame. So if we are going to render that and we want to turn on motion blur and we want to turn off deformation motion blur, because really we're just animating transforms, and if you have a large scene and the plane is not a ridiculously large scene, but there's some geometry there, so exporting the deformation information for every single time step within that frame, because you have to export more than the actual frame to the renderer for it to calculate your motion blur, this will take time. And if there's a lot of polys in your scene and a lot of them are deforming, or even if not a lot of them are deforming, this might take longer than actually finishing your frame, at least if you're rendering on a GPU. So I turn that off if there's nothing deforming in the scene, so it's going to be a lot faster. So that motion blur looks okay-ish, but it's still not correct. But let's just change a few things here. So instead of 360 degrees, this is just going to turn 1080 degree in the... Let me do that, Maya. This is going to turn 1080 degree, for example. So I'm just going to enable motion blur again. And this starts to look weird because that's not how a rotating thing looks. So the reason for that is we're just using 2 motion keys. So basically it's taking 2 time steps. Let's ramp that up to maybe 15. So as soon as this is ramped up, you can actually see the propeller doing its arc. So this is what a propeller in motion looks like. So you kind of like have to test your values. So if you put that down to 4, you can see it's starting to look just segmented, because there's not a lot, not a lot of time steps, and the renderer is kind of like interpolating the positions of this arrow linearly. So that means that if it's here on frame 1 and here on frame 2, and you would basically export a time step for these 2 frames, there's going to be motion blur between this position and this position. So there's just a linear thing. The rotor actually does an arc, so you have to represent it in the motion blur. So that works reasonably okay if you're animating with keyframes. So I'm gonna save that now, because that's right now is where things get interesting. So I'm just gonna delete this, and this is also a little introduction to expressions actually. So what am I gonna animate? I'm gonna use the rotate Z. So when writing an expression, you can actually use a little bit of code in Maya to tell your thing what it has to do. So that's pcube2. I should have called it. Let's in fact do that. It's just ridiculous. So it's rotor, propeller, whatever, rotary thing. Let's create a new expression. So it's rotor, rotate Z, and we want to give that some value. So the easiest thing to go about this is to just write frame right here. So it's going to take the actual frame number and just assign it to the rotate Z value, which means that basically on every frame, that thing is going to rotate a degree, and that's pretty slow. But yeah, it's going to do its thing. So if we want to make that faster, we might put that to a value of 10. So that's rotating faster. So if we maybe put that to 360 degrees, so that thing will have made a full rotation after 1 frame, and we are going to render it. That's cool. So basically that we know that this is correct, because what we see is a half rotation here. So we know that our shutter currently at 180 degrees, so it's open for half a frame. So that's a half circle arc, and that's basically what we should expect from that. So if we put that to 720, that thing will have done a full rotation on a frame. And as I said, that's not a problem. That's not. Well, this is a runtime expression, but it's using a fixed value, and even though the frame value is changing, basically on every time step in the future or in the past, when the renderer asks your program, what's the rotation value of this thing 1 frame before, or half a frame before, or half a frame last, this thing can be evaluated without any problems. It's just the current frame number times another number. So that works. That's just simple math, and that will never break. So you can leave it at that. You can bundle it up, send it to a farm, render it, render on how many machines you like. That's never going to be a problem, really. So let's change that a little bit. So if I want to put in, instead of what am I doing here? It's equal sign. So let's say instead of using those kind of fixed values, known constants, but want to add a number at runtime, which is what you want to do if you're just adding the RPM value. So basically you're telling the thing, listen up, the current RPM is 1000, for example. So please add this and this number of degrees to the rotor every frame. If we keyframe our RPM, or rounds per minute value, it will start to add larger numbers over time. But in the end, this thing will behave like a real rotor. So if I go in here to this rotor shape, and let's just add another custom attribute, and we're just going to call that RPM actually. and it's going to be a float. It's not going to be limited to anything. Or actually, let's just limit that thing. So it's 0 to 100. This is called RPM, and we're going to add the thing, and it's on extra attributes, and hopefully the expression editor will have already picked that up. So that's going to be rotor.rpm. Edit. So it's going to add a rotation, and it's going to add the number that I put in here. So it's currently at 3898 point whatever. So it's added 1. If I add 10, it's going to add 10. If I add 100, it's going to add 100. So the reason I can't get this back to its original value is because this is always overridden. This is never reset, so I'm always adding something right now. So currently that doesn't actually work at runtime because Maya does not want to evaluate that expression at runtime currently. If you want to know why, we can talk about it in the course and talk about expressions a little bit more, but that's kind of like the basis, or this is just about warning you about some pitfalls, about doing too much in expressions without thinking about the consequences later on. So let's say I do want to reset that rotation because I don't want my animation to start at 4004.638 degrees at the beginning. So let's just say if, so when the frame number is equal to, so that's is equal to 0. We're gonna rotate Z is gonna be 0 as well. So we're resetting the thing. So now if you take a look at that, this will actually run and work. So we're adding this RPM value every frame to the current rotation, and we're only resetting on frame 0. So if I just expand my timeline here for a little bit, and I'm going to set that to 0, and we're actually going to go to frame 0 because we have to reset that thing. So let me run the timeline here. So nothing's going to happen, obviously, and I'm going to use a somewhat more frames here, so nothing's going to happen, nothing's happening. So let me pull that value up over time, and this would of course be keyframe, but I can't do that just right now in the editor. So I ramp that value up, and I'm actually speeding up that propeller, and I can go down again, and it will start to add less and less and less rotation, and the engine stops. So if I pause here, you will see that this is a pretty large number right now. So it has added a lot of rotations per time step here. So if I want to reset this, I can go back to frame 0. And I'm going to save now because now we're going to talk about the problem with that. So this is all nice, and it seems to work quite perfectly. And actually it would be if those mentioned pitfalls wouldn't be part of the whole experience of working with Maya. So you can actually prevent it from doing problematic things during rendering, but I'll show you what these problematic things actually are. So I'm going to put this to 1. So on every frame, and if I step through here frame by frame, yeah, that's not actually frame, that's frame by frame. You will see that it adds a rotation of 1 every frame, and that's cool. That's what I want in this case. So to make things a little bit more obvious, let's add a rotation of 4 on every frame. So it's going to rotate 4 degrees on every frame. That's fine. And that's cool. So now I'm happy with that. That's actually a motion I want to have. So if I take a look at it, that's cool. That's not a propeller anymore because nothing turns that slow in the world of airplanes. But anyway, it's a thing, and that's the speed I want to have it turn at. I'm going to reset here. So we're adding 4 every frame. So let's check again. I wouldn't need right now, but let's keep it on 20 frames, 20 time steps. Let's press render and see what happened. So let's move forward again and take a look at the little time slider right here. It's pulling 20 motion steps between frames. So let me make that even more apparent. Let's put that to 100. See what happens? The motion blur completely changed. And that's really big problem, because this thing here, this runtime expression, this is currently evaluated every time step. So as long as I step through the frames in Maya's timeline, and it's just going to do frame 1, frame 2, frame 3, that's not going to be a problem. But Arnold, when rendering, tells Maya to evaluate 100 time steps between frame 0 and frame 1. So this expression is going to add 100 times, actually 102 times, between frame 0 and 1. And my propeller turns way faster than I intended. So the thing is, you might want to limit it by something. For example, you could times frame percent 1, so mod 1, so multiply it by the fractional frame you're on. This would actually not work the way it is, but that's just the concept. So if you're on frame 0.25, you're just going to add the fraction of 0.25 of that RPM value. You could do that. There are ways to do that. In some other programs like Houdini, if you're using a solver for that or something like that, that's not that much of a problem, because the solver is going to cache its result. So you can actually do that in a solver, and you can actually use fractional frames in a solver. So that's $FF in Houdini. You can in Maya too, because you can just factor in the frame number. But it's never going to evaluate the way that you want when rendering that thing. The other problem is, not only is the motion blur value wrong, if I just go to frame 300 here, and I'm gonna start my render there, because maybe I've already rendered until frame 299, or actually frame 300 in this case, and I'm on 301, and I start my rendering. It's gonna start at this position, and the first 299 frames will have already rotated my thing to a value that this is currently not on. So my first machine that is rendering that thing will gonna go in and say, okay, I'm happily rotating, and I'm rendering from frame 0 onward, and I'm rendering until 299, and I'm happy, and almost 299, 301 in this case. So let's say the other machine, so this one has rendered until frame 301, and the other machine is going to start at 299, so it's going to overwrite 2 frames, and it's going to load the scene. It's going to take a look at the scene and say, yeah, well, I'll just jump to frame 299, 98, 99. These 2 rotations that we just saw, maybe on frame 301, this is a completely different rotation. That has nothing to do with being rendered on frame 299. So really, without doing some crazy things, you can't render that. You can render that if you start at frame 0 and render your whole frame range on one machine, and you just pray that the thing doesn't crash. The chances are high it will crash. So instead of rewriting that expression, you can bake that down, which means you're breaking your rig before rendering. I did it for the propeller because I find it natural and easy to just use an RPM value instead of animating curves, but I do have to bake down the propeller. So what does that mean? So this is the animation as I like it. It's 4 degrees per frame, and it's doing its thing, and it's wonderful. So I'm gonna go to frame 80, so that's 4. And after frame 130, I want the RPM to have ramped up to, well, I limited it to 100, so yeah. It's gonna be 100, so let's take a look at that. So this propeller is gonna start to spin, and it's gonna be get faster, and that's its maximum speed, and that's what I want. And I know that will look okay with motion blur, so yeah. I can go to key, it's in the animation menu, set key, bake simulation, and I can tell Maya, look up, that's your current inputs. Take a look on every frame and everything that is animated on that thing. Just take that value and bake it down into a keyframe and destroy whatever connection there is to this initial input value. So whether that's an expression, a connection, or whatever, it's going to override it, it's going to destroy the connection, and it's just going to bake everything down to keyframes. So if I do that and go bake right now, you will see that Maya runs through the whole timeline, and it will have generated keyframes for everything. The expression is not going to be connected anymore, and as you can see, that's basically what I had before. Now I can render that because that's keyframes. So the transformation values or the rotation values of this thing are known. So in the end, I can have my one machine rendered to frame 299, and it's going to work, and I can have my other machine start at 300, and it's going to work. And especially if I take a look at Arnold now and take a look at the motion blur, that's what I would expect to see. So let's take the timestamps down a little bit. That's what I want to see. So it's actually consistent, it actually works. The motion blur is going to get more, and it's actually not doing more motion blur per frame that it actually should. So this thing now behaves correctly, but it means that you have to bake that down. So if you're working in your animation file and you want to go back to the rig, you've permanently broken the connection. So either you reconnect, you delete all those keyframes, reconnect your rig setup and have it that, or you keep a file as a backup before you've baked everything down, so you can go back and do your changes and then bake it down again and then re-render. So that's a quite technical thing, but still this applies to a lot of things that you can do in any kind of 3D software that will lead to problems at rendering stage. So you just have to be aware that there are certain kinds of operation where you have to be really careful on whether you can actually render that, whether you can split that to different machines, whether it's actually the good way to approach things. There would definitely be people that would tell you to never use the runtime expression in the way I did. There are definitely people that will always do that. It's a matter of opinion. There are, like I said, there are other ways to kind of like make this expression behave the way it should. And honestly, really, the translation from Maya to Arnold should actually respect the intent of the expression and evaluate it differently, but it doesn't. So that's what you're stuck with, and that's what you have to keep in mind when doing things like this. So that was a large tangent, but it's kind of important to understand how I set up the rotor in the propeller. So if you take a look, if I close that down right now, so if you take a look, and this is gonna be the start of looking at the node editor connections. So if you take a look at the prop tab, which is here, you can see there's this little expression here, and this basically does what my little expression that I wrote in the other file did. And it's basically adding a value on every frame, which is calculated from the rotations per minute value that I'm using here. And if I use that value, again, let me put that to 100. And let me not only put it to 100, but reduce the scaling factor. As I said, it's just as a scale for the motion blur to slow down the rotor so it doesn't make that many rotations per minute. As I said, I can't render that until I bake that down. So looking back at the prop tab right here, you can see there's the prop control. There's some math involved, which is fed into this expression node. That expression is directly influencing that rotor. That's the expression. It's a bit longer, a bit more evolved than the thing I put in the test file before. But basically that's that. And as I said before, at some point you can see expressions in the node editor. You can see that they are connected to their inputs, even though they're essentially just a bunch of code. But that's the way they keep track of changes. So even though this is a piece of code that I wrote, you might expect if a name of an object changes that it doesn't work anymore. It still will work because these connections are there. So the expression is basically informed by Meyer that the name changed, and it will change the name accordingly. So actually it's pretty hard to break these expressions. So they are really reliable. They look weird in Node Editor again. So you can also already see here, this is message connection. I'm not going to go into that. It's some internal Maya thing that Maya has to do for certain nodes. This is connected kind of like cyclic or backwards. That's not a problem, but yeah, that line kind of irritates if you're not used to that. So that's it for the propeller. And as you might imagine, I didn't want to bake down the wheels for all of the shots, so it's enough to bake down the propeller. You might risk just rendering it if you're just rendering on one machine, but as I said, as soon as your computer crashes, you're never going to be able to pick up at the same frame. I basically just wanted to avoid that. So having said that, let's take a look at the wheels, and let's take a look at how I did it differently without using that runtime expression to add values on every frame. So back in a second.